Okay, dear students, this is our physical science 10th class textbooks. So the first chapter is that we have a reflection of light at curved surfaces. In that one, so we are discussing about concave mirrors and convex mirrors. So now I will tell you about the differences between convex mirror and concave mirror. Okay, so this is about convex mirror and this is a concave mirror. Okay, let us list out some few differences between them. The first difference is that convex mirror is that which bulges outside. This will be reflecting surface, and whereas concave mirror is a mirror which curves inside, and this will be the reflecting surface. Second point, convex mirror always forms virtual images. Concave mirror forms real and virtual images depending on the position of the object. Real images. So what do you mean by virtual and real images? I will clarify in my next video, but now try to understand this one. Right, remember this. So convex mirror always forms virtual images, whereas concave mirror forms real and virtual images depending on the position of the object. And here convex mirror is used as rear view mirror in automobiles, that is in front of a driver, in front of the driver. And here concave mirror will be used by ENT doctors and other persons. So this is basically, many are there, but this is the major differences between the convex mirror and concave mirror. Okay, are you understanding? Now here let's define some terms related with mirrors. And here this is called concave mirror, where it is having some centered point, and this point C will be called as center of curvature, and this mid part of the mirror will be called as pole, and here there is a point here will be there called F, that will be called as focus, principal focus. Any line drawn from center of curvature onto the surface, that will be a normal to that mirror, means makes 90 degrees in the surface. Okay, well, no need to confuse about here. C, the term C will be called as center of curvature. Center of curvature. F means we call focus or principal focus, and P will be called as pole of the mirror. Pole of the mirror. And here any line drawn from center of curvature onto the mirror that will be a 90 degrees. For example, this is the line. If you draw a line like this, and this makes 90 degrees angle. Any line drawn from center of curvature onto the mirror surface will make an angle, and this will be called as normal to that surface. And here the line joining the pole to center of curvature, this line will be called as principal axis. What we call this one? Principal axis. Try to follow the terms. Here we are going to define about the focus and pole of the mirror with some ray diagrams. So how we get the focus? Let us define the term called focus. And here this is P means pole and C means center of curvature, F means focus. So here focus also, the ordinary term focus means where we concentrate the things or where we are focused. Okay, for example, there is a light rays are coming like this. There are many light rays here. So many light rays are coming like this. Okay, these are all called incident light rays, which are parallel to the principal axis. Of reflection from the surface, they will meet at one point. They will meet at one point, and here they are meeting at this point. So this point will be called as focus. That means it is a point. It is a point where all the light rays after reflection meet at this point or appears to diverge from this point is called focus, or that will be called as principal. That will be called as principal focus. Denoted with the letter called F. Here the length called, and here the length from pole to focus. Pole to focus, that will be called as focal length. If you measure the distance from here to here, F means here focal length, small letter F, that is called focal length. It is the distance from pole to the focus. So that is distance will be called as focal length. And similarly, the distance from pole to the center of curvature, that will be called as radius of curvature. R means here radius of curvature. R. It is the distance from pole to the center of curvature, denoted by letter called capital R. So generally the relation between the R and F is that F is always equal to R by 2 or R is equal to 2F, a very important relation in the objective bits. That means radius of curvature is double of its focal length, or F is equal to half of the radius. F is equal to R by 2 or R is equal to 2F. It is measured either in meters or centimeters. Okay, so try to understand that. Today in this class we discussed about the convex mirror and concave mirror and some important terms related with mirrors. What do you mean by center of curvature, focus, pole of the mirror, and here focal length, radius of curvature, and we discussed about this some ray diagrams. So some more terms I will discuss in my next class. Thank you very much.